At this video, I'm going to talk about calculating standard returns, I'm sorry, standard deviations and expected returns from scenario data, and then I'm going to talk about the Markowitz equation and how we use that. So let's just jump in here. I've got this example here of we have a scenario of several different possible economic outcomes, the probability that we could achieve those, and then the return. I've got two stocks here. I've got GPL and GDL, and I've got their return in each outcome. So in other words, if there is a bust, which there's a 10% chance that the economic condition will be bust, then GPL will have a return of minus 12% and GDL will have a return of positive 10%. Right, and so on and so forth. If the economy is good, there's a 25% chance of that. Then the return for GDL would be 14%. The return for GPL is 14%. The return for GDL is minus 4%. All right, and I want to calculate the standard deviation of returns for both of these stocks under these scenarios. Okay, and the first thing I'm going to do is calculate the expected return for each stock. And the way I'm going to do that is I just take each outcome or each possible return times the probability that I could get there. And I just add all of those up. So I'm just taking the return times the probability and adding all of those up. Okay, and then finally I'll take 18% times 10%, all right? So I just took minus 12% times 10% plus minus 8% times 25% and so on and so forth, right? And all of that will give me the expected return. All right, I want to mention here that there is a nice Excel function that will do that. It's called the sum product function. And it says if you give me two sets of items that you want to use, we just want to take each element in these two sets and multiply them together and then add them all up. It will do that for you, so it'll do exactly what I just did the long way. And you'll notice here that if I do that, I get the same result. All right. So I'm just going to do that. That's easier to type in here. I'm going to do the sum product for the other one also. And I can get their expected returns. Right. So there's the expected return for GPL. And here's the expected return for GDL, all right? And I'm just going to make those yellow. There's my expected returns. Okay. All right. Now what I want to do is find the standard deviation of these returns. Right, standard deviation of these returns. And I often have students who will say, well, that's easy. I know that there is a standard deviation function. And I can just highlight like that, but that is not correct in this case because we have scenario data and the probabilities are not all the same. Right? And because these are weighted by probabilities that are different, then we have to do this the long way. Right? And the way you do that is first you calculate the squared deviations times the probability. I'll show you how to do that. Right? And then the sum of the items we calculated in one, all those squared deviations times the probability, is the variance. And I don't believe I spelled variance right there. You know what I mean? Variance. All right, so I'm going to do that in each case to calculate standard deviation. So let's start with GPL. I'm going to first calculate the squared deviations from the expected return times the probability. So for each return, I'm going to subtract the expected return. I'm going to square that result, and then I'm going to multiply times the probability that that can occur. I'll do the same thing again. I'll take the next return, 8%. I'll subtract the expected return. I will square that result, and I will multiply times the probability that can occur. Right? Now there's actually a faster way to do this in Excel. So for the next one down, I'm going to take 6%. I'm going to subtract the expected return. I'm going to put dollar signs around that expected return so that when I copy this down, it won't move that one. It'll always look in H11 for the expected return, but it'll move where it's looking for the return. All right, I'm going to square that and multiply times the probability. All right, and now with the dollar signs in there, I can just copy this formula down. So I'm going to do that. I'll just drag it down here for the next two. And you'll notice it's taking the return minus the expected return, squaring the result, and multiplying times the probability. Okay? And so now once I have all of those, if I add them all up, I get the variance. Right? So the variance of that is just the sum of those results. And obviously once I have the variance, the hard part's done. I can take the square root of that variance, and that will give me the standard deviation. All right, and I'm going to highlight that and bold it. Okay, so I've done that one. I can do the same thing for GDL, and I'm going to do that. I'll do that in this column here. So these will be the returns looking at GDL. Again, I'm going to take the squared deviation. So I'm going to take each return. I will subtract the expected return. I'm going to go ahead and put dollar signs around that expected return. I'm going to square the result and multiply times the probability that can occur. Right? And since I have the dollar signs in here, I can just drag that formula down. So I'll drag it down. I'm going to format these so that they don't show up in scientific notation because some people don't understand that. I want to make sure I don't confuse you here. So there we go. Notice that this one's almost 0. It's very small. All right, so once I have those, again, if I add all of these up, I've got the variance. So I'm going to add all of those up. I'm using the sum function here in Excel. That gives me the variance. And if I take the square root of the variance, I get the standard deviation. And I get 4.94. And again, okay, so that is using the scenario data to find the standard deviation and the expected return and standard deviation for individual assets. Yeah, note here that this is GDL. Okay, and then typically what we'll do in this case is we'll say, okay, well, how about another asset that is a mix of GPL and GDL? So I'm gonna put here 50-50 mix. I'm gonna put half of my money in GDL, and I'm going to put half of my money in GPL, right? And the way to do that is to first find out what you would earn in each scenario, in each outcome. So I'm going to calculate the return of the 50-50, okay, in this cell right here. Well, if I have half of my money in GPL and there is a bust, then 50%, 0.5 of my money will earn minus 12%. So I'll have 0.5 times minus 12% plus the remaining amount. In this case, it's 50-50. So another 0.5 times the return of GDL. Half of my money earns minus 12%. Half of it earns 10%. So there's how I calculate the return in that case. So there's that return, okay? Now notice, I can't just copy this formula down. I'll walk through it just to make sure one last time. 0.5, if there's a poor outcome, then 0.5 of my money will earn minus 8% plus 0.5 times 4%. So I have half earning minus 8%, half earning 4%. And I'll end up with 2%. Let me turn those into percent so that they look nice. Okay, and I hope you can see that I'm just getting halfway between these numbers, which is what you would expect if I have half in each, okay? And I can just copy this formula down since it's just taking half and half. You can see what I'm doing here. Okay, I'm always just taking half of 50% of the return in the first asset plus 50% of the return in the second asset, and That will give me my returns in each state. All right. And now I do the same thing I did with these. Okay. Now I can treat this just like another asset as if it were one of these. If I want to take the expected return, so if I want to calculate the expected return of that, well then remember I'm just going to take the return in this case times the probability it could happen, plus the return in this case times the probability it could happen, plus the return in this case times the probability it could happen, and so on. And that, if you remember, is the sum product function. Does a very nice job of that. All right, so I'm going to do the same thing here. I'm going to say the sum product of, well, all those probabilities, comma, all of these returns. Right, and that'll give me the expected return of a 50-50 mix. Right, and in this case, that is 2.2%. Okay. Now, I want to point out that for the expected return, you can also just take a 50-50 mix of the other expected returns. So I'm going to just do that calculation here. I can take 0.5, half of my money's in GPL, so 0.5 times its expected return, plus the other half is in GDL, so 0.5 times its expected return. I should get the same number. And I do, all right? So that's just, I could also do it that way. All right. And now I also want to get the standard deviation. And now a common mistake is to say, oh, well, I can do the same logic here. I can just take 0.5 times the standard deviation of GDL plus 0.5 times the standard deviation of first GPL and then 0.5 times standard deviation of GDL. And it turns out that this does not work. Right? That this does not work. You will get the wrong answer if you do this. All right? So I'm going to just let's see, I want to color that red and strike it out because that's not the right way to do it. You can do this for expected returns. It works for expected returns. It does not work for standard deviations. Okay, you have to do it the long way for standard deviations. So that's what I'm going to do here. I'm going to go through the exact same process that I did to find these standard deviations. I'm going to do that with the 50-50 portfolio. Right, so I'm going to do that here. I'm going to take the squared deviations times the probability. Right, just like I did before. Now notice I have, here's my returns for the 50-50 mix. Let me just color all of these. Say that color there, because we're talking with about the 50-50 portfolio. All right, and I'll take the square deviations from its expected return times the probability. So I'm going to take each return minus the expected return. Put dollar signs on that expected return. I'm going to square the result and I'm going to multiply times the probability that it can happen. Right? And just to be clear, I'm going to do that again. Let me format these so that they look like the others. All right. So I'm going to take that return minus the expected return. I'm going to square that result and I'm going to multiply times the probability that that could happen. Okay. All right, and then since I've got the dollar signs in there, so it'll always look there for the expected return, I can just drag this one down. Right, and notice, remember, if I sum these up, that is the variance. So I'm going to sum all of those up, and that will give me the variance. Color that, I don't know, this color. All right, that's the variance. And if I take the square root of that, that will give me the standard deviation. Okay, and notice is not the same as this. All right, this was where I just said, oh, well, it's got to be half of this standard deviation plus half of that standard deviation. That's not true. It's a lot less than that, actually. This, if I put it in percent, halfway in between those standard deviations is 7.6%. But actually, when I invest half in GPL and half in GDL, I end up with a standard deviation a lot less than that. And this is a key insight here in why we go through all of this, is to show the benefit of diversification. that by putting two assets together, I can reduce the risk. So I've got two assets that are risky, and I end up with less, by owning both of them, I end up with less risk than either one, right? And the reason this works is what we call correlation, right? And so I've just got a copy of a slide here, right? When we talk about correlation, we're talking about the tendency of things to move together. And we usually measure that with what we call the correlation coefficient. We use in finance, we use the Greek letter rho. Okay, it looks like a little p, all right, but it's the Greek letter rho, the lowercase rho. And it has a nice property of being between -1 and 1. Okay, so rho is always between -1 and 1. It's usually a number like 0.2 or 0.7 or -0.3. Okay? If it is exactly -1, then that means that the returns of these stocks move exactly opposite each other. That is, when one goes up, the other goes down, right? And vice versa, right? If the correlation coefficient is exactly 1, and then that means they move exactly this, or they move in the same direction all the time. If one goes up, the other goes up. If one goes down, the other one goes down. All right? That's if they have a correlation coefficient of 1. Right? If they have a correlation coefficient of 0, that means you can't predict the behavior of one based on the other. Just because you know that one went up, it doesn't give you any information about what happened to the other. They are completely, we call that completely uncorrelated. They're just random to each other. Right? They don't move together at all. Right? Okay, and it's rare, if not impossible, to find assets that are exactly -1 or 1. But typically they're somewhere in here. And so the closer they are to 1, the more they move together. And the closer they are to -1, the more they move apart. Right? So if you've got assets that have a correlation coefficient of, say, -0.9, well, then that means that most of the time they move in opposite directions. Not all the time, but most of the time. And if you have two assets that have a correlation coefficient of, say, 0.1, well, then that means that, okay, they move together more often than not, but really they don't have a whole lot to do with each other. There's very little correlation between them. Okay, and if you go back to, if we go back to these two returns, I'm going to make a quick chart here, looking at these two sets of returns here, just to show you what I'm talking about. So I just made a chart of these returns over all these outcomes, and you can see that as the economy gets better, this series is getting higher returns, but as the economy gets better, this one is getting lower returns. So they move opposite of each other. They're not exactly opposite of each other, but pretty close, right? So they're pretty much opposite of each other, and they tend to cancel each other out. That's why that standard deviation is so much smaller. Right? Because you can imagine if you own half of each, you're always going to get in between these 2 points here. And that's pretty much a line just right down here. There's not much movement in the resulting return there. So there's not much standard deviation in that resulting return because they tend to cancel each other out. This went up, this went down. It tends to cancel out to a very small return. Right? And so that's what's happening here. Okay? All right, and so that's calculating these the long way, and then we talked about correlation, and there was a researcher in the 50s named Markowitz, and he was an economist, he did a lot of research on this, and he came up with this equation that explains these, and he says, if I know two assets, I know their expected return and standard deviation, and I know the correlation between them, then I can find the portfolio standard deviation without having to go through all of those steps I just went through, right? And it follows this equation. Now, students always hate this equation. They say, oh, that looks terrible, but it's really not that difficult. You're just not used to looking at these things, but it's just one term at a time. So if you look at this WA squared, it means the weight in asset A squared. So for instance, let's say we had 60% in asset A, and we had 40% in asset B. All right, well, if that were the case, then this weight A squared would be 60% squared, right? The weight in asset A squared, all right? And so we're going to take that times this sigma squared A. Well, that means the standard deviation squared, which is also the variance, okay, of A. So this would mean you would take 60% squared times 8% squared. And then I'm going to do the same thing with B. I've got 40% in B, so I'm going to take 40% squared times 30% squared, because its standard deviation is 30%. Right? And then I have this term here, plus 2 times rho times the weight in A times the weight in B times the standard deviation of A times the standard deviation of B. Okay, it's just all the same terms you saw again, except for rho, right? But you just put them all together, right? And typically in these kind of problems, all of these terms are given to you. There's nothing to figure out, right? Students often are confused with rho. They don't know exactly what it is or where it came from, and I hope you understand that it's the correlation between those two, and there is a way that we could teach you to do the statistics to calculate it, but it's kind of complicated and tedious. So typically we just give that to you. All right, so you'll have this equation here, and you'll have everything you need to know. You just have to plug it in. Right now, I have found that if I try to type all of this in one long Excel formula, 90% of the time I make a mistake somewhere. Right, so what I do is I break it down into 3 parts. I calculate this term, and then I calculate this term, then I calculate this term, and I add them all together. Right, and that limits the number of mistakes I make, and also if I do end up making a mistake, it's usually in this one because it's the longest one, and I can double check that and try and find my mistake, right? So I'm going to go through the example here of if we were doing this and we had 60% in A, in this case I guess I should say, let's call asset A is ABC, and asset B is this YYZ here, okay? All right, so I've got these 2 assets, I've got their expected return and standard deviation. I know the correlation coefficient between them, it's minus 0.3. So that means that not all the time, but a lot of the time, or at least a decent amount of the time, they tend to move opposite of each other, right? Because it's minus 0.3. All right, and I can find the standard deviation of a portfolio that's invested 60% in ABC and 40% in YYZ. So I'm going to do that. All right, the first thing I need is this weight in A squared times the standard deviation of A squared. So that's going to be 0.6 squared times, I'm just going to click on it, the standard deviation of A squared. Right, so 0.6 squared times 8% squared. Right. By the way, the most common mistake here is to forget to square something. All right, so the next one's going to be 0.4 squared times the 30% squared. Right? That term. Okay, and then this last term, notice there's no squares in here. You just multiply everything together. So it's the number 2 times the weight times rho, which I'm just going to click on it. Rho is minus 0.3 times the weight in A, well that's 60%, times the weight in B, well that's 40%, times the standard deviation of A, which is 8%, I'll just click on it there, times the standard deviation of B, which is 30%. Right? So that's that term there. Right? So now I have them all. If I add them all up, there's that number there. Notice this is there's a squared here. This is sigma squared, so it means the square of the standard deviation. This is the variance, right? This is the variance. The result from the Markowitz equation is a variance. But that's okay because once we have the variance, we just take the square root of that, and that gives us the standard deviation. All right? And so there's my standard deviation. Okay, notice I can also find the expected return of something that's invested 60% in ABC and 40% in YYZ by just taking 60% times the return of A, in this case ABC, plus 40% times the expected return of YYZ, right? And that's 16.4%. Okay, so there's my standard deviation. And here's my expected return. Color there just to make the point. There we go. Okay, and by the way, I want you to notice what you've done here is that notice that by mixing these assets 60-40, I get a standard deviation that is a little bit higher than A's, but not a whole lot higher than A's, but a whole lot less than B than YYZ. All right, so I've really eliminated my risk, but I get a return that is a good deal higher than A. Right? Now notice it's not as high as YYZ, okay, but it's a lot higher than A without taking on a whole lot more risk. A little more risk, but for the return that I've gained, it's worth it. Right? So it's a nice thing about it's the whole idea of diversified portfolios in finance, right? Because they're slightly negatively correlated here, they tend to cancel each other out. You really improve the risk of the portfolio by putting these together. And if you put it together the right way, you can usually do better than owning either one of these assets by itself in terms of a risk versus return. Okay, that is the whole point. Okay, so that's an introduction there to calculating these standard deviations and using the Markowitz equation. And I'll leave it there.